So Trig, welcome to your last video lesson of the year, and hopefully the last video lesson for me in your life, because next time we see each other for class, I hope it's face-to-face, in person, because I just think that works a whole lot better. So I hope you enjoy your summer. I hope it treats you well. I hope you spend some time with God and spend some time on other important projects and are ready for senior year and good things ahead. But here's our final go-around. So today, you can ignore the little first bit of 3 notes on the notes sheet, because like I said a little bit yesterday, we're caught short on days. We're not doing the full matrix chapter that we might have if we just had some more days. So you don't understand the difference between those Gaussian elimination versus Gauss-Jordan versus multiplying inverses, because we didn't even do all those lessons, so that doesn't really matter. What does matter is some words of the day. Every system of equations means more than one equation, more than one variable, is either consistent or inconsistent. Up until today, pretty much everything you've ever seen in your life has been consistent. Consistent means it has a solution, at least one solution. It might even have more than one solution, but it's solvable. Inconsistent means there's no solution to it. In some way, it turns out to be nonsensical. So you can see in the left margin next to inconsistent, I have a row where it's like 0, 0, 0, and then the number 6. That would be crazy if you had no x's, no y's, and no z's, and 0 of everything, and somehow that equaled a number like 6 or 5 or 2 or 3 or really any number. So inconsistent means it's sort of crazy that way. Additionally, there's another pair of antonyms, dependent versus independent. Every system is either dependent or independent. Pretty much you're used to seeing independent systems. Independent systems are where all the equations are different. None of them are ever going to vanish as you're solving along. Dependent means you may get an equation just kind of vanish as you're solving. There's essentially an extra equation. Or you might get a row of entirely all zeros. That would make it be a dependent system. But the way we're going to attack these systems is go back to like what we were doing the first day of solving systems with matrices. When we did that, we always left the top row alone. And what we tried to do is use this top left corner, hopefully a 1 or our smallest number, to make there be zeros underneath it and make ourselves a simpler system. So if we wanted to use a 1 to wipe out a 3, we would need to multiply by -3. Because if we multiply all of these things by -3, we'd get a -3 that can add down and create a 0. I'd get a -6 that can add down and make a -2. I'd get a -15 that could add down and make a -4. And I would have half accomplished my mission by using a -3 to kill the 3. But I'd also need to use a -4 to kill the 4. If I multiply by -4 and add down, I'd get 0. Multiply by -4 is -8, add down is -2. Multiply by -4 to get -20, and add down, and that would be -4. And then I could look at this and notice a couple things. One, I'm looking for dependent or independent. Dependent would mean some stuff is the same. This is definitely the same as that. So this is a dependent system. Second question I'd ask myself is, could I solve this? This would mean -2y equals -4. -2y equals -4 again. That's definitely telling me that y would have to be 2. This is telling me x plus 2y equals 5. And if y is definitely 2, I definitely have x plus 4 equals 5. I definitely have an x of 1. I can solve that. So that is a consistent system if I can solve it. And it's dependent because it had a couple things that were different. We'll do a few more. It's all the same concept. Again, the concept is leave the top row alone and use this top left corner to make the numbers under it become zeros. For a 1 to kill a 2, I'd have to multiply by -2. So -2 wipes this out. Multiplying -2 makes -4, would wipe this out to make another 0. Multiply by -2 makes a -10 to add to this, makes that a 0. and that's sort of weird. I got a full row of zeros. So we check the notes. The full row of zeros thing means that this is a dependent system. These two equations are basically the same. 1x plus 2y equals 5. That's the same as 2x plus 4y equals 10. There's no new information here. I just multiplied that top row by 2. These two are really telling you the exact same thing. This equation depends on this one in a sense. They're dependent. If I wanted to try to find answers, I can't solve it the way I solved this one to get a single answer, but there are answers that work. 5 and 0. 1 times 5 plus 2 times 0 makes 5. 3, 1. 1 times 3 plus 2 times 1 makes 5. There is actually an infinite amount of answers here, so this is still a consistent system. If we thought about graphing things, which we haven't done for a while, but if I graph this, I get a line. If I graph this, because it's the same thing, I get the same line, two of them stacked on top of each other, and those share an endless amount of locations. Unlike this, if I graph these, I get one line from this, I get another line from that. They'd only share that one location, so that had one answer and made it consistent. This has endless answers, but it's still consistent. For this, again, I'll continue to copy that top row, but create a 0 underneath that top left corner. For 1 to kill 2, we need a -2. So multiply by -2 and add, that would be -2. Multiply by -2 and add, that would be a -4. Those are most certainly different. We did not get a full row of zeros or anything like that. So these are independent because they're different. And then this is solvable. If I inserted a y, we could see for sure the y is definitely 2. If I plugged in a y of 2 and solve for x, the x is definitely 1. I definitely solved that, so that is consistent. There's no pattern to which word goes with which word, by the way. So this was consistent, but dependent. This was consistent, but independent. And even though this one was dependent, like this one was, and they were both consistent there, you can't expect it to always go that way. Every choice is a choice of its own. Again, top row, I'm just copying. The 1 wants to knock the 4 into 0 world. The 1 wants to knock the 2 into 0 world. For 1 to kill 4, I need a multiplication by -4. So multiplying gets me -8 to add down. Multiplying here is -12 to add down. And then I forget all about that and shift gears into -2 town to kill this off. Multiply by -2 to get -4 to add down. Multiply here to make -6 to add to that. And then I look this over. Everything's different, so that is independent. But this is telling us y is 2, while this is telling us y is 1. That is inconsistent. That's a little bit crazy. You can't have y being 1 and 2 simultaneously in the same problem. That is an inconsistent type of a thing. That's crazy. If I go after this one, top row, just keep it. For 2 to make the 4 a 0, I need to multiply by -2. So I'll multiply this by -2 and add down, that's another 0. I'll multiply this by -2 and add down, that's -19. These are different, so that's independent. But this is crazy. You can't have no x's and no y's equal anything other than 0. So this is inconsistent. That's nuts. There's no way 0 x's plus 0 y's can make -19. And again, even though these were both independent and came up inconsistent, don't think there's a pattern to it, because there's not. Because take a step back here. These were independent, but it was consistent. So that's just not a thing that's going to go. I think that'll do it for us. So the homework sheet, the front of it, you only have to answer independent or dependent. When you get to the back is more like the board. It wants to answer inconsistent, consistent, and the independent, dependent. And if you can solve it fully to get a single answer, like I did for this one and this one, you do look to do that. Now that's your end of your year. So tomorrow's class would have just been showing up and like turning in this paper. So that's all you're doing. So see you guys.